Okay, so now let's move on to section C. C question 1. Figure below shows an arrow indicating the direction of travel of a wave in a medium. J is a particle of the medium that is in the path of the wave. Okay, so um, what's the meaning of this question? Okay, I'm going to explain to you. Um, okay, there's a wave. Okay, so the wave that you usually see is like this. Okay, but now they don't show you in this form. Okay, they are telling you that okay, the wave is moving from left to right. Okay, and J is a particle. Okay, so along this wave there are a lot of particles. Okay, there are a lot of particles. So they are just focusing on one particle. Okay, so they are just focusing on one particle, and they call this particle J. And then they actually uh, take the J out. Okay, and they show you over here. Okay, so remember this. There are a lot of particles. Okay, on a wave. Okay, every single point is a particle. Okay, so they are just isolating one point called J, and they're asking you questions about it. In the diagram below, draw arrows to show how the particle J vibrates when the wave is a transverse wave. Okay, so for transverse waves, please remember that the direction is perpendicular to the uh, way whereby the J vibrates. Okay, it's perpendicular to the vibration. So if the direction of the wave is in this manner, okay, then J should be vibrating up and down. Okay, because over here it forms a 90-degree angle. So this is perpendicular. And longitudinal wave, okay, J is actually vibrating left and right. And this is parallel to the direction of the wave. Alright, so this is how you answer the question. Okay, now let's move on. In part B, the figure below shows the displacement distance and displacement time graph of a wave. So again, take note of the keywords. Displacement distance and displacement time graph. So there are two types of graph. Okay, one is displacement distance, the other one is displacement time. Alright, both graphs okay are used to find different things. Alright, so later we will see what are they used, what are they for. Okay, from the figure above, write down the amplitude. Amplitude is rather easy. Maximum displacement to its original position, so is 0.6. Okay, and what's the wavelength? Okay, for wavelength, which graph do you use? Okay, this one or this one? Okay, which one? Okay, this one or this one? Which one? Okay, for wavelength, we know that we are trying to find the length, and for length, we know that SI unit is meters, and we have to use this graph, okay, to find wavelength. Alright, because over here is displacement distance, and we have to make use of the distance to find the wavelength. And we can see a number over here, 0.1. So is this a wavelength? No. Okay, so what we are trying to find out is the one wave. Okay, what's the length of one wave? Okay, and how many waves are there over here? Okay, we can see that there are actually, okay, this is one wave. Okay, and this is the second wave. So two waves occurs in 0.1 meters. So one wave, what is the length? 0.1 divided by 2 equals to 0.05 meters. Okay, so the wavelength is 0.05. Okay, now let's move on. Now we are trying to find the period of the wave. Period, we cannot use this graph. Okay, for period we have to use this graph because period is related to time. Okay, and what's the definition of a period? Period is the time taken for one wavelength to occur. Okay, period is the time taken for one wave to occur. So here we see this number 7.5. Can we just write down 7.5? Okay, please do not make this mistake. Okay, for period is the time taken for one wave to occur. So where's the one wave? So one wave is actually over here. So we want to find the time taken for one wave to occur. Alright, so 7.5 seconds, how many waves have been generated? Okay, so this is one wave, this is the second wave, this is the third wave. So 3 waves are being generated in 7.5 seconds. Alright, so 3 waves generated in 7.5 seconds. So one wave is equals to 7.5 divided by 3 equals to 2.5 seconds. So one wave is being generated in 2.5 millisecond. Okay, so it's not second, okay, it's millisecond. Okay, because the axis over here says it's millisecond. Right, so let's go on to part 2. Find the speed of the wave above in meters per second. Okay, find the speed of the wave above in meters per second. Okay, so to find the speed, we have to make use of the formula called V equals to F times lambda. Okay, so we have the wavelength. So the wavelength, how about the frequency? Okay, we don't know the frequency. Okay, but we know the period. Alright, so to find the frequency, we have to make use of this formula. Frequency equals to 1 over period, and is shown by the working over here. Frequency equals to 1 over period, so which is equals to 1 divided by 2.5 times 10 to the power of minus 3. Why is it 10 to the power of minus 3? Because it's millisecond. Okay, we have to change it back to seconds, so we have to times 10 to the power of minus 3, and this will give you 400 hertz. And after you have found the frequency, we can just substitute in the values. So the frequency is 400, wavelength is 0.05, taken from here, and when you multiply both together, you get 20 meters per second. Okay, so the speed is actually 20 meters per second.